Hi everyone. So I've promised you that I'm going to show you also the table method with which you can solve linear inequations, specifically those with the cases like we had in the last lesson. So before I go into it, so you can write down today's lesson is basically table method. Before I go into the table method, I have to go through the things that we did already last term, specifically considering linear function, because we're going to use the function as a base for the table, and it will give us some properties, and we did these properties, so it shouldn't be anything new, but let's go through it just in case for everyone who maybe missed it or forgot it to remind ourselves what's going on. So let's start with the example 1. Let's start with the example, and I'm going to start with simple inequation. Like, for example, 1 over 2x plus 3 is less or equal to 0. Let's start with that, okay? Now, we can solve it, and you can always solve it. Now, this is just for the table method. I'm going to have to show something else. You can directly go and solve it. So basically, minus 3, 1 over 2x is less or equal to minus 3, multiplying with 2, x is less or equal to minus 6. If I want to write x as a part of the interval, x is element from minus infinity to minus 6 included. Okay, so this is something simple, and this is what you usually do, or method that you usually go for to be able to find the x's. Now, I'm going to now show you how to do it like using a function. First thing, I have to define a function. This is the first thing that you have to do. This is going to be our linear function. Okay, now I'm going to write it down that f of x is equal to 1 over 2x plus 3. Okay, now I'm going to use this here in equation, which now says, instead of writing down 1 over 2x plus 3, that we have given, or we have to find out what is going on when f of x is less or equal to 0. Now I have rewritten it down using the function. Okay. Now, how do we solve this? Basically, what we do here, we can always use the graph, and this is the idea. This is going to be in the end give us the table. Now, the graph itself is going to look now in your notebook. You can always draw this perfectly because you have the you don't have the empty paper. You have the net, so to say, of the coordinate system which you can use. Now let me write everything I need to here down. Here is going to be my 1, here is going to be also my 1, and the 0. Okay, now now we should be able to draw it quickly. So basically 3 is the y-intercept. This is the y-intercept, 3. I have to go 2 to the right. 1, 2, and 1 up, because it's a positive. And this is going to be my my line. Now, always remember to write down that this is the graph of f, function f. So don't forget about this. Now, this is a sketch. Now, where is this graph, or the function itself, less than 0? Now, first thing that we have to remember is that f of x is also y, or the y values, okay, for the graph. Now, where are the y values? Well, here are the y values. Where are the y values? Less or equal to 0. Here they are, okay, including the 0. So 0 would be in all of this. But here are the values that are less or equal to 0. Now, where on the graph is going to be just that? Well, basically, all the points on the graph which y value or y coordinate is less than 0 are going to be part of this solution. So these are all these here points, okay? Basically all of them, all of these. Now, I have to find the x, for which is that. X is always the argument which tells you what's going on, whether we are going to have positive things, negative things, and so on. Well, if I look at like this, okay, if I just look at where these x's are here. Now we have the, so to say, ending, because the beginning is in minus infinity, so I don't care about that. So minus infinity is going to be here. Now last thing is I have to find this here value. I'm missing the x for the intercept. This is also going to be x-intercept. Now how do we get that? Well, this is something that you did learn how to find. And basically we know one coordinate of this here point. So if here is the x value, we don't know the x, y value is definitely 0. So for every point on the x-axis, the y value is 0. Now I can apply that. So basically what we have that here y is equal to 0. Well, this is also f of x or y, and it is all equal to 0. Now I can use that. Now how am I going to use it? 0 is equal to 1 over 2x plus 3. Minus 3 is 1 over 2x multiplied by 2. X is equal to minus 6. Now this is specifically for this point, for the x-intercept. This is specifically for that. And we're going to use the x-intercept. And next term, or in the second grade, you're going to learn that this here point is also called zero of a function. Zero of a function. Because for this here x, the value of the function is itself 0. Okay, now we have found that here is minus 6. Here is minus 6. Now one last thing is in all of this is, so here are all the x's. Am I going to include the minus 6 into all of this? How to be able to determine it? Well, the inequality tells you, if in part of the inequality is equal, this means that we're going to use the minus 6 also in it. Now, how do I note myself that I'm going to use the intercept itself? Is basically in Croatian language, what does mean also included? I. Ubacimo i njega u rješenje i napravim si jedno veliko i u tome svemu. Evo, napravim si njega. Zašto si ga napravim? Odnosno, ovo je kao rimski i. Well, now I have the bracket which I use, okay? So the result of all of this, if I use the graph, is that x is element from minus infinity to minus 6, included. Evo. E sad, where is the table in all of this? What's going on? Basically, what's going to happen and what we're going to use is we're going to look where the function is either positive or negative. So if I look at this here graph, the negative values are here. Here are all the negative values. Here are all the positive values, okay? On the other side, here are the negative, here are the positives. So from minus 6 to plus infinity are going to be positives. From minus infinity to minus 6 are going to be the negative values. So I'm looking only at the negative ones. This is it. Now, this is not a table, still not a table. Let me show you the table for this. So, first thing, I'm going to get rid of all things that I don't need in this. I don't need actually to draw this line perfectly. I don't care about it. The only thing is that I do care is that the sketch is correct. Or that the graph is either ascending or descending graph. Now, who in all of this is going to tell us whether the graph is ascending or descending or positive or ascending, descending? It is the coefficient before the x, okay? Or the slope itself. Don't forget about it. We have the slope. Slope, and this is the intercept. So slope is the guy who tells us whether the graph it's going to be ascending or descending. Now, one thing that I do need is the x-axis. It is needed. The x-axis is needed. Y-axis, I don't care about it that much. because the x-axis determines all that is beneath it is the negative, all that is above it is positive, okay? Now, one more thing that I do need to point out is the x-intercept, another thing. So x is needed and x-intercept is needed. While, okay, we already calculated. This is going to be the method of how to calculate it. Okay, y is equal to 0, so you can always apply that. So the only value that I care about is minus 6. I'm going to put minus 6 here. I'm going to put that it is included, okay, because if we have less or equal. Another thing, now this is the beginning. I have this. Now the last thing that I need is the sketch of the graph. Here we go. This is the sketch. Now, the function itself, f of x, I'm going to put it on the side. F of x. Now these are the values of the function. I'm going to extend the minus 6 part. I'm going to put the bracket also, not actual bracket, but let's make it like this. And here you have the table. This is the table. Now this is the simple table. Now what do I put into the rows? Well, the sign, whether the function is positive, values of the function are positive or negative. So when you look at the line here, it is beneath the x-axis, so the values are negative here. On the right side, graph is the line or the graph is above the x-axis, so the values of the function are going to be positive. The task that was given to us says that we are looking only at the negative values. Well, included. We can only look at the less than part strictly in this here case, but if I put this here, it is going to be included. Now the x's have to be the result of all of this. This is why the x-axis is needed. And if I interpret it, this is the line, number line. So from minus infinity to minus 6 included are the x's. Here we go. And this is the table method. Now, this is the simple method. I'm not going to force you to use it in simple inequalities, okay? Don't use it. It's going to be extra time, but this is basically the task itself. This is the task itself for if you wanna use the table. Now, where this is going to be useful is I promised you that I'm going to show you in the tasks that we already did using the case method. I'm going to show you now using the table method. So this is the task 22.1. where you have x minus 1 times x minus 2 is greater than 0. Now this is given now. Now, what are we going to do now? Instead of the case method, now how many linear functions are given in this task? This is going to be the first one. This is going to be the second one. The first one is going to be f of x. The second one is going to be g of x. Okay, so these are two linear functions. Let's write them down also. Let me write down. So f of x is going to be x minus 1. I don't have to use the bracket actually. I'll just put it in the bracket so we have it. G of x, okay, I'm going to leave it without the bracket, is x minus 2. So I'm going to go with the table method. First thing, before I go and draw the table, is I'm going to find the x-intercept for each of them. So the x-intercept is basically 0 equals to x minus 1. I have to find the x. So x is equal to 1. Okay, this is the x-intercept for the f function. Let's find out what's going on with the g function. 0 equals to x minus 2, so x is equal to 2. This is the x-intercept of the g function. There we go. Now we are ready for the table. Now, one last thing that I want to rewrite this here down, and this is something before the table that you should always do, is that instead of now looking at the linear equations that are multiplied and they have to be greater than 0, let's look at the functions. So the functions themselves is f of x times g of x is greater than 0. So the result of the multiplications of these multiplication of these two functions should be positive. This is going to be basically we need to find the pluses in the end. Okay, number line, the x-axis basically. Now there are two values that are in all of this. So these are the values that we have to point out, and these are 1 and 2. Now let's draw the table. Let's draw the table till the end, and then I'm going to put everything inside and solve it one by one. And this is how I'm going to basically advise you to do it yourself if you're going to use the table method. Okay. So somewhere on the side, let's put the f of x. Let's put the g of x. And in the end, let's put f of x times g of x. This is going to be the last row. So we have two rows with f of x, g of x, and f times g of x. Okay. Also, let's draw the columns. Basically, these are the three columns that you need. You can also draw this in the end if you want to have it as a table itself, to fill it in as a table. So you see it's a table, all of this, but it's not necessary. Some of these lines are not necessary for us. Okay, let's start with the function f and see what's going on with the values f of x. So f of x, its x-intercept is 1. Okay, let's draw the line. So the line, we are multiplying x with 1, which means that the slope is a positive number, which means that the line is going to be ascending line, so to say. So the sketch itself can be something like this. Okay, this is the sketch. Draw it a little bit further. Okay, draw it a little bit further. Now I'm going to concentrate only on the function f at the moment. Now point out, this is the graph of f. And so from minus infinity, now on the x-axis, let me extend it. So from minus infinity to 1, the values of the function f are negative because they are beneath the x-axis. So minus here. While after 1, in both of these cases, they are positive. Here is a plus and here is a plus. Okay. Let's look at what's going on with the g function. The g function itself, its x-intercept is in 2, so here is going to be in the intersection. Okay, then we can make it like, it doesn't matter how does it look like that much. It can be like this. Okay. Let's draw it like this, doesn't matter. By the way, they are parallel if you want to draw it in coordinate system. Now, in this here case, from minus infinity to minus 1, the values are, so the graph itself is beneath. Let me point out, this is the graph of g. So because the line is beneath the x-axis, here is a minus, still beneath, here is a minus, here is going to be the plus. Okay, let me find the result of all of this. So if I multiply two negative numbers, the result is positive. If I multiply positive with a negative, the result is negative. And if I multiply two positive numbers, result is positive. So one last thing in all of this, don't forget about it, is what is going to be with the intercepts themselves. Are they going to be included or excluded? We are given the strict inequality. We don't have equal as part of it. So I'm going to just cross them off. Why am I going to cross them off? So this is now the new sign that I'm going to use, or new symbol, so to say, whatever you want to call it, is, well, it is going to give me the result. Okay, it is going to give me what is going on and what is going to be with the brackets. So the result is values of, when I multiply function f and g, the result should be positive. This is given in the task. So plus and the plus. So here are the results. Now how to interpret the results? Where they are on the x-axis, and they are the x's. So these are going to be all from minus infinity to 1 and from 2 to plus infinity. Let's write it down, and not on, and I apologize, it is going to be or between them. So x's element from minus infinity to 1 excluded, union, because it's or, 2 to plus infinity. There we go. And this is the result. Now, if you compare this to, let me find, if you compare this to the case method, with a lot of things going on, watching out for the intersection, watching out for the union in the end, or, and so on, while here, this is the task itself, I think it should be clear why I'm showing you this method. Now, before I go into the task that we already have done last time, another case task that I'm going to show you as a table, let's just look at another example of something like this. Now, I'm not going to use your textbook tasks. You're going to have some of them for your homework, which is going to be posted on the Lumen. Now, let's look at just the example 2. Now, the function is the inequations are going to be this. So 3 minus 2x times 4x plus 10 is less or equal to 0. I'm going to go with the table method. I'm going to name the functions. So this is going to be the first one. This is going to be the second one. F of x is equal to 3 minus 2x. And the second one is g of x equals to 4x plus 10. So let's go through the method. First thing is the x-intercept, which means 0 equals to 3 minus 2x, which means that 2x is 3 and x is 3 over 2. So this is the x-intercept. The second one, or the g function, its x-intercept is going to be 0 equals to 4x plus 10. This means that x is going to be minus 5 over 2. Okay? You should be able to solve this and find it yourself. So, we found the intercepts. Next thing, so one last thing that I wanna do is write down the inequation using the functions. So f of x times g of x is going to be less or equal to 0. So I'm looking only at the negative results between multiplication f of and g. Okay, table. First thing is the x-axis. That's the first thing. I'm going to go on a side, write f of x, g of x row, and f of x times g of x. Now I'm missing the intercepts. Let's point out the intercepts. We have 2 of them. The first one is going to be minus 5 over 2. The second one is going to be 3 over 2. Let's extend it. Okay. I'm not going to complete the table because it's not needed. And let's draw the f function, or the line, the graph of the f function, and it is, so its x-intercept is 3 over 2. So this is going to be the point with it, going with it. So first thing is, what is the slope in this here case? It's minus 2 times x, okay? Which means the slope is going to be descending, okay? So let's draw a sketch of a function that looks like this. This is the line. Let's point out that this is graph of f, and now fill in the table. So in the first part, in both these here parts, the inside of the table, well, graph is above the function, above the x-axis, which means the values are going to be positive, while in the last one it's going to be negative. Let's see what's going to be with the g function and its graph, or a line. Now it's minus 5/2, and the slope says that the graph is ascending. Something like this. It doesn't matter. So this is f, the graph of g. Now, for it, from minus infinity to minus 5/2, it's beneath, so values are negative. While after that, they are above x-axis, so they're positive. Now, if you multiply, positive with a negative number, result is negative. Positive with a positive, result is positive. And negative with the positive, result is negative. The task itself told us that we are looking only at the negative values, including 0. We're going to get to the including 0 in the end. So these are all the negative values that we're looking for. The minus 5/2 and 3/2, are they going to be included? Yes, they are, because we have equality. So I'm going to write myself big Roman I. And, well, these are the x's that give you negatives, or these are the x's that give you negative results. So x is element from minus infinity to minus 5/2 included, union 3/2 to plus infinity. And this is the result once again. So this is the example, so you can get used to it and try it yourself. Okay, let's go with the last task that we did in the last lesson, and that was the task 23-2. Where 2x plus 1 divided by 3x plus 2 is less or equal to 0. Now, when you look at this table, you don't look at the cases. Basically, here are the cases. Here are the cases going on, but it's a table. I don't care about it. I don't care about union, intersection, what's going on between them. I just look at the result in the end. So, let's write down the functions. F of x is going to be 2x plus 1. G of x is going to be 3x plus 2. Let's find the intercepts. For function f, the x-intercept is going to be 0 equals to 2x plus 1, which means that x is minus 1/2. So this is the x-intercept. Let's find the for the x-intercept for g function. 0 equals to 3x plus 2, which means that x is equal to minus 2/3. Now, if you compare this to the case method, these are the values that we already also found there, okay? So this is nothing new. So far, so good, okay? It works. So let's write down what is actually asked of us in the task, and that is that f of x divided by g of x is less or equal to 0. Okay, so we are going to look at the negative solutions of the division, or negative quotients for all this. Number line, or the x-axis. On a side, f of x, g of x. And now, instead of multiplication, we're looking at the division, f of x divided by g of x. And this is going to be where we are looking at the results. Two numbers I have to point out that are... Now, of course, guys, you don't put them correctly on the number line, okay? You don't put them correctly. You put them so that you can write down a beautiful or systematic table. Okay, that's why you did it. Now I didn't use the color green. The coloring is just so it makes it easier for you to understand. You don't usually use the colors. So let's write down the values. So minus 1/3 and minus 1/2 in correct order. That's the important part. Let's draw the rows. We have now the rows. and start with the function f. So a graph of the function f goes through -1/2, and the slope is greater than 0, which means the graph is something like this. You can always draw it furthermore, it doesn't matter. And let's see what's going on. So in the first two cases, the graph is beneath the x-axis, so the values of the function are negative. So these are the values of the function. They are negative. While after -1/2, they are positive. Let's look at the line for g function. Sorry, I keep forgetting. I have to get used to it. So this is the graph of f. Similar to the f function, it is going to be increasing or ascending. So something like this. Doesn't matter. They don't have to be parallel. They are not parallel, and it doesn't matter how to join. The sketch is the important part. So this is graph of g. The first part, now here it is beneath, so it is minus, and after -2/3, it is positive in both cases because it's above x-axis. So if I divide two negative numbers, result is positive. If I divide positive and a negative number, doesn't matter the case, the result is negative. And in the last case, two positive numbers give you the positive result. Now we are looking only at the negative solution because we are looking at the less or equal to 0. So this is going to be the result, part of the result. Now, last thing that I have to point out, you can also do it at the beginning. Doesn't matter when you do it, okay? You can also already at the beginning say whether -1/2, -2/3, and -1/2 are going to be included or excluded. Now, the simpler or easier part is deciding what's going on with the function that you are dividing from, okay? So can the function f, values of the function f of x, be equal to 0? Yes, they can, which means that here we have the including part, okay? Well, can the g of x values ever be equal to 0? They cannot, because we cannot divide with the 0. That's why the x-intercept for the g function is not going to be included. Sad, ovo je nešto što morate malo si posložiti u glavi. Ovo je specijalka u ovome svemu. Znači, za množenje je full jednostavno. Kako je ovdje, tako i jedan i drugi. Dok kod dijeljenja, onaj s kojim se dijeli, njegov rezultat, odnosno njegov x-intercept, nikada ne možemo uzeti u rješenje. Evo, tako da znate da se tu možete malo pomoći sa time. Tako da uvijek njega možete izbaciti iz priče. Sada, from all of this, we see the brackets that we are going to use. So x is going to be from -2/3 to -1/2, excluded and included. And there you go, guys. This is how you use the table method. Now, for your homework, I'm going to give you a couple of tasks on the Lumen, and I'm going to ask you to try and use this here method, to get used to it if you can. Of course, you can check the results using the case method and see what's gonna happen if you do it. And I'm not going to force you to use specific method. You can choose whatever you like to do, and this is going to be your method. I'm not going to stress it out. Oh, you're not using this or you're using that. No, it's up to you. But my personal favorite is the table method. I have learned the table method in the 2nd grade when I was in high school, and from then on till I finished university, I never used the case method if it wasn't absolutely necessary. Of course, in mathematics, there are situations where you have to use the case method because it's so complicated, especially when you are studying mathematics. But for us in high school, the table method is really good and it can be really simple. And I hope you can learn this way. I would like you to drill yourself using this here method, because in the long run, it's going to be quicker, it's going to be simpler, and you're going to see next term And from, yeah, in the second grade, third grade, and in the fourth grade, we're going to go back to the inequations a lot. And the table method is something that I'm going to go back to each time when we learn the new tricks and new inequations. I'm going to go to that because in some situations, the case method is going to be so complicated and so long that basically one task is going to be full of calculations. Full this here page is going to be just the equations, okay? Or inequations or calculations to get to the result, something like this. While the table is going to stay as simple as here. Now, why is also table going to be important? I'm going to show you just the equation. I'm going to just write the equation down so you can see why the table might be better. Is what if you are given an inequality or an equation like this? What if you're given multiplication of 3 linear factors and that the result has to be greater than 0? Trust me, the table method is much better or quicker because you have f, g, and h functions. Just add one row to all of that with the h of x, and you're going to be able to solve it. So guys, thank you for listening, participating. Watch out for the homework, and hear from you guys soon.